Which one did you have a question about? 6. All right, let's talk about 6. 6 is an interesting problem because it has a reflection. It has a vertical compression. It also has a horizontal compression. So when we think about our normal moves for a square root, square root of 1 is 1. The square root of 4 is 2. That's a little hard to see. Let me switch to white. Square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Those would be our normal moves for a square root function. But our y's get multiplied by negative a half. So it's going down. And our x's also get multiplied by a half, or divided by 2. Because when we factor this 2 out, so that we can see what our horizontal shift is, we also see that the x's were being multiplied by 2. And when a move affects the x's, we always do the opposite. What is the opposite of multiplying by 2? Divided by 2. So we would take each of our x's and divide by 2. Well, 4 divided by 2 is 2. 9 divided by 2 is 4.5. So if I went right a half, I go down a half. If I went right 2, I go down 1. If I went right 4.5, I would go down 1.5.
Okay, that makes sense.
Okay?
Thank you.
You're welcome. And did you guys have any problem solving
Nope.
for your x or y intercepts? Awesome. Awesome, awesome. All right, let's take a look at the last ones, which are our cube roots, inverse of our cubic function, correct?
Yes.
These were fun.
Wait,
They just wiggled all over the
Wait,
place.
what's the 10?
That's a graph.
I know, but it has like a curve to it.
Yeah.
This is pointing to right here.
Oh, okay.
Yeah, it's saying right here is where we started.
Alright, I was confused.
That's what it's doing. Right there is where we're starting. All right. Today is kind of cool. And still kind of math.
Class outside?
So math.
Class outside?
Math outside.
That's outside question mark installation.
You know what here it is?
Spring.
All right.
You know what's not fun? People are allergic to the spring.
Everyone's allergic to spring.
Everybody.
Yesterday I couldn't breathe, but today I'm doing
Okay, so today we're going to look at a function that has to do with rounding. This function can be called the greatest integer, or it could also be called a step function. But it really has to do with rounding. And we really have 3 kinds of rounding: rounding to the nearest, rounding up, rounding down. We're going to look at rounding up and rounding down. You just kind of watch, unless you want to take notes.
Oh, no, I'm not taking those.
Okay, so our rounding up. What symbol means rounding up? Well, it looks like this. The little things at the top. It means rounding up. Okay, so not only we're going to look at rounding up, we're also going to actually graph some functions that are rounding functions. They round up. It's the greatest integer x that is greater than or equal to. All right? And then rounding down. There are 2 symbols that mean rounding down. We can look at it this way. That means rounding down, or this way. Both of these mean down. So if we solve things like this, if we rounded this number up to the next integer, what would it be? 3. If we rounded this up to the next integer, what would it be? 1. If we rounded this up to the next integer, what would it be? -3. Okay, so all those are rounding up. Rounding down.
Yeah, what? 0 first. 2.2 is 0?
Okay.
3.
I said 3. I said 3.
Zero.
Yeah. And then wrote 0.
That was confusing.
You wrote
Thank
3, don't worry about it.
Thank you.
It's been there the entire time.
Yes, that's right. All right, same numbers, but this time we're rounding down. Let's see if I can write the correct ones. 2. This time we're rounding down, so let's use a down symbol. There we go. 0. It has been all day long. That's what has happened.
-4.
-4.
I have a rounding
Three.
problem.
-3.
Because down.
You're
Down.
rounding
Down.
Down. All right, number 1.
just kidding. I was kidding.
Oh, good. Thanks.
Making jokes.
Put her hand down, and she was like, about to stand up.
Like when you're rounding down, you put brackets.
These symbols mean down. These symbols mean rounding down. And you'll see it with like a double bracket. Double. Also.
So they mean the same thing.
Correct. But a full bracket or the bracket with just the little legs at the bottom, those mean down. The bracket with just the little legs at the top, that's the only symbol that means rounding up. Okay? That's a good question. Probably should research that before y'all come in and ask me a question right now.
You'd ask why.
Okay.
True.
So all these are rounding down, right?
Yes.
Okay.
What's that dual?
Alright. So when we round down, what happens with our graph? We can use either of these symbols, but what we end up with is this really cool thing that looks like a little barbell. And we start with the closed, and we go right to the open, and you're about to see that happen, and it'll make sense. Versus rounding up, we start with the closed, but we go back to the open. And you're about to see that happen also, so it will make sense then. So we're going to start with the parent graph, because that's the one we always like to start with. And let's start with this one. Is it that up or down?
Down.
Down. This is a rounding down function. So first of all, we have to understand, because we can't do anything until we understand.
Absolute value.
So let's look at some values for x and think about what our y would be. If we plugged in x and we round 0 down to the closest integer, what would it be? 0. All right. 0.1. What would it round to? 0. 0.34. 0. 0.67. 0. 0.99. 0. 0.9998.
0.
0.
I was about to
1.
say hurricane.
1.
1. Okay? So everything along here, 0 is 0. And then every other little point along this path rounds to 0 until I get to what? 1. And then what happens?
Open.
It's open and it jumps up to 1. And then everything between 1 and 2 rounds down to a y value of 1
Are we gonna have to
until I get to 2. And then what happens? It jumps up to 2. And then everything rounds down to 2 between 2 and 3 until I get to 3. And then what happens? It jumps.
This seems really
Okay,
time-consuming.
so this is, once we get it, it's really fast.
This is
So it
really
makes these little stair-looking things, which is probably why we call it a step function too. And it goes from rounding down, gives us the little barbells that go from closed over to open. Now, we could continue this pattern the other direction. It would look like this. And if we're ever in doubt, we can check, test a point and see if it actually makes sense. Would negative 0.5 right here, this x value, round down to negative 1? Yeah,
Yes.
that makes sense. Okay, so that is a rounding down function. That's what it looks like. Was there any restriction on what we could plug in for x? No, I can plug in anything, can't I? So my domain is everything. Now, if you wanted to, you could say all reals. Double R, all reals. Now, let's think about what came out of this function. What the range of this function is. Did we just got out integers. It is the set of integers. And the symbol for the set of integers is a z. It's a z with a double little whoop, like that. What's on the board?
Who makes these symbols?
You're just so cool.
So, There we go. So if you felt like writing that, you could. All right. Question. Oh yeah.
If you were finding y-intercept, and you plugged in 0 for x, what would you?
We plug in 0, we get out 0.
But he knows the.
No, yeah.
Okay.
Okay. Now let's talk about what things that could happen. What would that do? Instead of jumping up 1,
You jump up two.
we jump up 2. All right? Let's think about what this would do. Instead of going over 1 unit, we would go over 2. Okay, we'll do some of these in a second and make sure they make sense. What would something like this do?
It would move it left.
That means this point right here would move left 1 and down 2, and it would actually start right there.
How would we know?
It doesn't look the same.
It won't look the same because I'd start right here, and it would jump here, and then it would jump here. Would it be the same?
No.
And then it would jump. No.
I know, but how would you know what your
No.
starting point is if it's like?
If you're okay, Eric has a good question. If you're just looking at the graph, do you know where your starting point is?
If you
No.
don't have an equation,
No.
then-
Put it
So,
forward.
how many equations could represent this function? An infinite number.
a good amount.
Yeah. So many.
So many.
All right. So that's rounding down. Let's examine rounding up.
It's like the opposite, right?
It's the exact.
All right.
same.
All right.
Kind of not, but no.
Exact same.
All right. -1.
We have that proverb word.
Rounded up to the nearest integer. Well, the nearest integer to -1 is -1. But -0.9 would round to 0 if we're rounding up.
Messing with us.
-0.2 would round to 0. Would round to
0.
0.1 though
One.
would round up to 1. 0.88 would round to 1. 0.97 would round to 1. 1 would round to 1. But 1.1 2. Okay, so let's take a look at this. When I start with the 0, 0 here, that is a solid point. Let me switch to pink. It's a lot easier to see. That's a purpley pink, actually.
I thought green was easier.
You think green's easier?
Yeah.
All right, green, it is. But that's green and black, which are really not my favorite color combo.
I don't know why
Thanks, Doug.
Okay.
St. Patrick's Day.
Okay, so let's look at the zeros.
Customize our own color in the little cup line.
The zeros go this way, don't they?
Yes.
Until we get to the -1, and then it dropped down to -1. So we start with the closed circle, and we work back with our bar. So when we jump, it's an open circle, and it's over to a closed. When we jump, it's an open circle over to a closed. Now let's verify that all these are right, because we don't believe everything Miss Willoughby says, because some days, like today, she has a really off day. So let's make sure she's telling you the truth.
Yeah, I had an off day during the test, and I retake it.
Me every day.
All right. So, yeah. I'm just pretending like I can't hear you now. All right. So, if we test some points that live inside this graph, like 0.5. 0.5 would round to 1. Oh, it does. Good. 0.97. Ooh, it rounds up to 1. Good. I'm trying to get green. It's not obeying. How about 1.2? It would round up to 2. Yes, it does. 1.8 rounds up to 2. Yeah, my graph's good. All my points are rounding up to where I need them to be. So, with the rounding up, you'll start with the closed, but then you'll go to the left to do the open. Okay? We're going to practice a couple that are on your homework sheet together. And then you'll have the rest of class to work on this.
You need dumbbells, they're closest I've gotten to exercise in weeks.
Josh is higher. Really, don't you like tennis?
No, he's not.
Yeah.
Yeah, I said that. Probably bad time. He's trying to tell this man that I was.
Yeah, well, you out, so I can watch
Yeah, just don't say it for the teacher.
Okay.
I remember when I had
We get the idea for this, guys, and rounding functions, step functions like this, actually make a whole lot of real world sense because a lot of times things are rounded up to the next hour. So if a repairman comes to your house to work on your plumbing, they might, if they work an hour and 20 minutes, they'll round it to 2.
I would pay them for one.
I would pay them. My mom would.
I would not want to use the plumbing in your house after that. Alright, so a lot of times if you go to a parking deck, you'll see they have between this and this, it's this amount, and then it rounds up.
I would try to keep the arm.
Are you guys going to visit Doug when he's incarcerated? Or? Okay, good. Alright, that's good. I like Doug. I visit him. Okay. Now, this equation right here, is it, first of all, is it rounding up or rounding down? It's an up. And with an up, we start with the closed and we go backwards to the open. Okay, so where do we start with that closed dot?
Down to right 3.
Right 3 and down 2, or down 2 and right 3. Now, we're going to verify that what we're saying makes sense. So, let's test one. If I plug in 3, 1, 2, 3. If I plug in 3, do I get out negative 2?
Yeah. No. Yes.
Yes. Okay, let's see if I plug in 2.5. If I plug in 2.5, I get out negative 0.5. What is negative 0.5 rounded up to the nearest integer? 0. What is 0 minus 2? Negative 2?
Yes.
Is that where the bar is?
Yes.
Yes. So it does make sense. Now, is there any number out in front?
No.
No? So what do I jump up by? 1. Okay, so my domain, there's no restriction. Negative infinity to positive infinity. I don't have that much room, so I'm writing the double R. All right, range. Does this range give me every single integer if I kept going forever in both directions? Yes, it does. So it's a set of all integers. You can write set of ints if you want to.
Yeah. You do number 2.
And 3.
Will you get it if we just... Do we have to do it like a fancy C or...
Yes. All right, now I'm not doing this one, but let's talk about it. There is a negative out in front. So instead of jumping up, we will jump down. Instead of jumping up down by a whole, we're going to jump down by half.
So when you see,
Okay?
you see negative, then you just like cross it out and have 2 lines to the round up. Never mind.
Okay.
Never mind.
I'll think about what you said, and I don't think so.
Probably not get back to you.
But, all right. Now, is this rounding up or rounding down?
Down.
Down. So down, we start with the closed, and we go right to the open. Up, we go left to the open. Down, we go right to the open. Okay, so where does that first closed dot start?
Negative 1, 2.
Negative 1, 2. Closed. Now, normally we go over 1 unit. But this one has a horizontal stretch by a factor of 3. So instead of being 1 unit across, it is 3 units across. So we're going to stretch that horizontally. And we're going to go over. 1, 2, 3, open. Jump up, jump down. How do I jump? Up. Okay.
It's like a
Close.
rap song.
1, 2, 3, open.
You were so destructive.
Up. Closed. 1, 2, 3, open. If I'm going backwards, I go open, back 3, closed.
Do we have to do every single thing?
Okay, I am going to test a point because I want to make sure I'm good here. So let's choose an x value of 3. If I plug in 3, 3 plus 1 is 4. 4 divided by 3 is 1 1/3. If I round that down, what 1, and 1 plus 2 is 3. Is that where my y value is? Yes, it works. Woo! All right, domain, everything. Range, set of events. Or the double Z.
Double C's growing.
Okay, now, if I jump by 2, think about this. If I jump by 2, my range is either going to be the set of even integers or the set of odd integers. It just depends on where I start. If I jump by 2, does that make sense? But sometimes we jump by weird numbers, like a half. Or there's one later on where we jump by 3. Now, we're not going to be able to describe this in words, so we give the pattern. So let's do number 5 together so we can see what's going on with this one. Is it rounding up or rounding down?
Down.
Down. So this is down. So remember, down is solid, over to the right to open. Where does that first solid start? -2 and -4. Solid, over to the right to open. How far right do I go? 2. Very good. Now when I jump, how do I jump and how far do I jump? Down 3. 1, 2, off the graph. Solid, over to open. So if I went backwards, I'd go up 1, 2, open, back 2,
3.
solid.
Oh, 3.
Oh, 3. Thank you, 3. Open, back to solid. 1, 2, 3. Open, back to solid.
How many points are you usually going to want us to give?
Enough where I can see a good pattern.
Like 3.
So, domain, no restrictions again. Negative infinity to positive infinity, set of all reals. Range. Range, I'm just going to have to give a ... It goes something like this. This y value is -7. This y value is -4. That y value is -1. That y value is +2. And it keeps going. So because we can't describe that in words, we have to give ... dots. It goes something like this. Okay, you have the rest of class to work on this. I'll answer any questions if you have them. The front is more practice with greatest integer, step functions. The back is a little bit of review.
I have a proposal.
I have a feeling it has something to do with outside.
I actually have a rounding problem then. Technically, there